Thank you for joining us for the last session of the day. Fiber-driven security, building smarter, safer infrastructure. Our presenters today are Gail Arendelle, the Market Development Director, Enterprise Networks at Corning Optical Communications, Katherine Aschbeck, Market Development Specialist, Enterprise Networks at Corning Optical Communications, and Xander Alexander, Technical Evangelist at Motorola Solutions. As a reminder, please fill out the evaluation forms that are on the BICSI application. These are important for us within the organization to make sure that we're delivering what needs to be delivered to you folks to do what we do in the ICT industry. So please join me in welcoming Gail, Katherine, and Xander.
Good afternoon. I think I'm on. Yes, I'm on. So good afternoon. Thanks for sticking around, holding it through to the very, very end. We appreciate it. We thought we were going to have like 2 or 3 within the room, and so we have far exceeded that. Anyway, so my name is Xander Alexander, like Bob said, and I'm a technical evangelist with Motorola, and I focus on Pelco. So up there you have Xander Alexander, just Pelco. I'm not just Pelco, but I am an ambassador of Pelco. And basically we go around and we talk about security in many different forms, which is how we linked up. So what I want to start with is talking about the shift. The shift from, or let me rephrase it this way, the shift where you have IT, OT, and physical security, all of those things converging. And so if we were to step on a campus, what you'll see are cameras, which I like to call mini servers, but you'll see cameras, access readers, you'll see blue light phones that are out there, and outdoor Wi-Fi and many different sensors, hundreds of different endpoints that are out there. And so it's no longer just video over here and business data over there. It's the backbone. It's one backbone that they both share. When these systems, when they talk, security becomes what I like to call OI, operational intelligence. And so the question isn't, can we connect it? No, the question is, can we power it? Can we secure it? I am very bad with clickers, as you see. So I'll give you something to look at. So once again, the question isn't, can we connect it? The question now turns to, can we power it? Can we secure it? Can we have the ability to scale it without all of the complexity that goes behind that? And that's how we build smarter, future-proof security throughout everything that we do. Once again, convergence. It's over here. I'm pointing over there, but it's over here. Anyways, so what exactly has shifted at the edge? What has changed at the edge itself? Today, the camera, once again, that I like to call a mini server, it's a sensor, and it's a very, very ambitious sensor at that. A lot of the things that, especially with Pelco cameras, well, kind of with any camera that you get video security-wise these days, you have these higher resolutions that are out there. You have multi-imagers that are out there. You have thermal access. You have on-camera analytics that are taking place. And all that means more bandwidth. All of that means more power that has to happen over a longer distance. And so if you're trying to protect perimeters or ports or utilities, your switch is typically there and the pole is all the way over there. And so trying to maintain the bandwidth throughout all of this. The expectations that installers and integrators have is that this has to work powerfully. It has to be able to scale. And so we have to begin to treat the edge of connectivity like an asset and for it not to be an afterthought. And so you have the camera, and the camera isn't just seeing. Now it's now deciding. We look at the Pelco cameras, for example, since that's what I hear and that's what I represent. It has a tremendous workload, powering things like LPR with license plate recognition, doing crowd and traffic insights, having different behavior cues, machine vision, having personal protection equipment. That's hard hats and jackets, and then firearm detection, all these things that are happening on the camera itself. And so we've moved from just being able to record and store to now we've moved to detecting, to classifying, to having trigger alerts. And that's absolutely fantastic, but the outcomes, they are very much demanding on the infrastructure itself. Because all of this intelligence, it only works when the plumbing can keep up with it. Let me say it this way. It only works when the camera gets smarter and the network gets stronger. Hopefully that makes sense. So let's move on and talk about how their outcomes first. Outcomes such as maximizing the uptime, having faster responses. Outcomes like operational efficiency so that we have reduced loss and so that we have cleaner workflows. And then workforce protection and compliance, these things that actually stick. So this is where security earns a seat at the strategy table because the system drives measurable results. So why do strong designs still stall within the field? I'm gonna throw this out to anybody. Anybody want to shout out as to some guesses, some responses as to why designs still stall within the field? Or not, and we can just go the awkward silence. Yeah, both of those. Give me one more. Let's round it out with 3. There we go. My guy, appreciate you. So installers, which I very much appreciate installers and integrators, because we talk, at least at my level, we talk a lot about theory, right? There's some practices and some R&D that all goes behind it. But when it's in the hand of installers, when it's in the hand of integrators, that's where our theory then meets the trench itself. The trench could be a tight space that they're trying to get something through. It could be long runs as far as the cabling is concerned. It could be power that happens up to be in a wrong place. It has bandwidth that spikes. And so much of these are operating in what I envision as a triangle. And this triangle, it has, in no particular order, bandwidth. It has power. It has distance on those 3 sides. So, and they are often operating within super harsh environments that get all type of weather. We got a snowstorm coming a little bit further south. And so it has to be able to operate within all of those environments. Is there any particular environment that anyone within the room, sorry I'm making you guys talk a bit, but is there any environment that you specifically see a challenge in?
-40.
True. I have a camera that operates at that level.
Honey.
Plus 40. Yeah. Plus 50. Yeah. So all these things have real world pressure that goes along with it, which is why the next answer, it isn't just luxury, it's table stakes. And so, at least with Pelco cameras, you have fiber that checks all of these boxes for modern security because our cameras, although a lot of processing happens on the camera, it still has to send it upstream and it still has to get things downstream. And so how can we keep that bandwidth high and then have low latency? Because we have cameras that have 4 or 6 different lenses that are operating on there. Not only that, but we have sensors that are always, whether it be audible or whether it be a mic and just hearing it and not saying anything out loud with a speaker. It still has to be able to ingest all of that and send that upstream at a lower bandwidth. And then you have the long reach so that there's low loss. Really bad, once again, we're here. My apologies. So we have the long reach that has low loss so that campuses, so that perimeters are able to operate without having to stack different IDFs that are out there. And then a harder tap so that this is operating at the transport layer on the OSI model. And so all of these things pair up very well with fiber so that you have smart power strategies so that you can get clean designs that you have the ability to scale. And so here's the truth before I pass it off to Gayla. the truth is that what you see on the pole, the camera, the access reader, the blue light phone, is just the tip of the iceberg. Because underneath the surface, you have the things such as media converters and power aggregation and preterm options that are out there that make these long reaches more deployable. So I'm gonna pass it off to Gayla and Catherine, and they're gonna peel back the layers so that we can dive into it.
Thank you so much, Xander. That was very motivation. Okay. So as Xander said, we think about this in the terms of an iceberg. And you'll see there all the different devices at the tip of the iceberg that Xander was talking about, the camera, the access control, the surveillance, etc., audio. And then how do you connect it all? So we're looking here that, what we're talking about is the transition from a, say, traditional copper backbone to more of a fiber backbone to really attach. The word fiber attach is attaching all these devices. And when you look under the iceberg, there's a whole lot of just materials and fiber components that we will go through today with you to show why a fiber attach is really the way to go in a security network, or at least transition for some of the applications within the security network. So this is the part that's not working.
Yeah, no worries.
Okay, so let's today you'll hear from us, from Catherine and I, and Xander's input as well, about three main applications here. One is using a remote power with a hybrid fiber and power sort of cabling network that will then connect Ethernet switches or media converters at the edge of the network. So then you can power and give bandwidth to your device. The second one is to address some of the other challenges that we see today in the networking industry, which is the lack of skilled labor. So we have some pre-terminated solutions that we'll talk to you about that kind of take that splicing and using connectors and such out of the hands of the installer, but you get it delivered pre-terminated. And then last but not least, I'm going to introduce to you about fiber optic sensing. So when we're thinking about a camera at the edge, let's assume we're just thinking about this camera at the edge. There's a couple of things you'll see here on the vertical. I'm talking about how you connect it in terms of the fiber. And then on the horizontal, I'm talking about the power. So the first box here is you have a camera and a pole, and you do have a power supply at that pole. So one solution would be to connect the pole with fiber, and then from there you would connect the camera at the pole. We'll talk a little bit about that. The second one is that you don't want to use splicers. You don't have capable workers. It's hard to get them. We're going to talk to you about this pre-terminated solution, again with power at the pole. And then the other ones would be where you need remote power. So the third option here is where you are remotely powering that pole using this hybrid fiber and power solution. And then lastly, you could do that same remote powering using a pre-term solution, but also then sending the power over a separate type of network. So a couple different scenarios, and we'll highlight some of these here for you today. So with that, I'm going to hand you over to Catherine. She's going to talk about the first option.
Right, thanks, Gayla. So starting with that first option and kind of going through the components and again, kind of reiterating those challenges and where you might see scenarios where you're going to choose and likely want to go towards this type of solution. So this is the remote power, hybrid cable, and media converter type of solution. The big challenge that we're seeing here again is that distance limitation. If you're thinking of just using, the copper side of that, which can work for some networks if you're going, just that 300-foot distance, right? That's totally great, and that definitely works. If you're going beyond that 300-foot limitation, think of a few different scenarios we'll find that in. That copper side doesn't always, that makes it a little bit more challenging to actually get across that. So distance limitation being big, you're not always going to run into that if you're just going to a parking lot, a campus. That's usually much larger, in a lot of cases, past that 300 foot. Also, that space constraint, right? Your conduit or your pathway, a lot of times, especially in legacy networks, as we know, that's pretty full oftentimes. And having to actually fit something into that, especially thinking of big bundles going out to multiple devices, out to your edge of your network, to those cameras per se, right? And how can you find ways to reduce that? We'll talk about that as well, and how hybrid cable can help you with that. And also limited local power. In a lot of cases, power isn't already out there. In some cases it is, but in other cases it's not. So what are other ways using fiber and power combined to, bring that power out to the edge of your network versus having to have a complex power system set up in order to support those devices with the power needed. Some of the scenarios you might find this in, parking lots, garages, a classic one you might see, not maybe necessarily the crazy complex, type of network you might think of, but a lot of times is a big network that we definitely see in this space. Warehouses, campgrounds, manufacturing, industrial facilities, airports, large public venues. A lot of these places is, places that are obviously implementing cameras. Everyone's implementing cameras, and these places, especially airports, and Xander might be able to speak to this too as well. But, type of cameras or type of scenarios that they're implementing even in these security applications that you might see.
Yeah. So these here are, I would say, the classic long reach sites that you see on here. Obviously, there's more with perimeters and garages, campuses, as Catherine said, airports as well. And so the edge, just from my standpoint, it continues to get smarter. But where the switch isn't necessarily moving closer, and this is really moving more and more and further out. And so this is where I would say that fiber plus the remote power gives integrators, gives installers that extra edge with fewer IDFs, cleaner paths, and designs that actually have the ability to scale.
Right. Yeah, and you can see how this is kind of working here, and we'll get into some case studies right after this. But first, kind of going into the key components here and what that means. So first being that long reach flexible cable infrastructure using hybrid cable. So that uses hybrid cable that's class 2, class 3 usually. Class 4 is something I'm hearing about a little bit more, getting into maybe some more transportation or ITS scenarios are going miles and miles with a distance limitation on that. Class 2 and 3, I think we're seeing more regularly, I think, in the security space, though, again, depends on your application. But what this does is combines your fiber and power into one cable jacket. So going back to that space constraint as well, and then also the distance limitation. So now I'm not limited necessarily to that 300-foot limitation. I can go 2,000 feet and beyond that, much surpassing that, being able to get to those more hard-to-reach applications or locations. What that does too, in thinking of not just a one-to-one scenario, now I can fit multiple fibers, multiple power units in one cable jacket. I can actually streamline that infrastructure. Let's say we've seen up to even 70%, reducing your actual linear feeding cable needed. 2, being that low voltage DC power, reducing cost and the complexity with that remote power. So again, with the cable and with the power, being able to go far beyond that 300-foot limitation, right? Bringing that back and centralizing that power. So thinking of, I don't know if anyone saw the Apple presentation earlier today, we're talking about eliminating, some IDF closets or IT closets that are needed for a lot of these scenarios. Same thing, even for security cameras, sometimes that does require having some crazy complex power setups just to get the distance that you need and the bandwidth that you need as well in order to support these applications. So these two things together really help that. But how do you convert that back to PoE, right? These devices at the edge that you'd be connecting, these cameras that usually, for the most part, though some now do have just an actual SFP integrated into it, depending on how advanced you're getting with the camera that you're actually integrating. But oftentimes you need to convert that back to PoE at the edge. So number 3 being connectivity at the edge, we're seeing a large trend in use of fiber media converters. And really to that is to convert that back to the type of connection that you need at your edge of your network. So you're almost bringing that PoE connection further into your network. Now your 300-foot limitation starts. Now I can go connect out from whatever zone area that I might need, let's say in a parking lot, airport, etc., whatever scenario you might be in. Some applications that we've seen deploy this type of solution, for instance, and it goes even beyond this, but for instance, there's an automotive manufacturing plant. So for them, they're deploying Wi-Fi for updates pretty much on their vehicles that come off the line. They go into the parking lot and there's data that needs to pretty much process that as well. And also the security cameras that go on top of that too. So started with Wi-Fi, now they're doing the same exact thing for the security camera system that goes on top of that. So you can think about the power requirements that are needed for that. And in this case, it was 40 watts of PoE, but the max distance was clearly far over 300 feet. So it was over even 2,000 feet in these hard to reach pole locations. So each pole having a Wi-Fi as well as cameras on top of that too. With that, they use this hybrid cable, remote power, and media converter type of solution in order to reach these poles. From there, obviously being able to expand that limitation, but also was able to future-proof their network. So again, I told you they started with the Wi-Fi, but then they had separate fiber and copper ready there already. They didn't have to pull another cable to go implement that network. They already had that fiber and power capacity available where they can now deploy the camera network that they've already done. So they have the bandwidth, they have the power that they need. They were able to future-proof their network. They didn't have to pull anything separate. Another example of this is powering perimeter security through intrusion detection. So this was pretty much smart integration is what was needed with embedded sensors and multiple IP protection devices. And that's something we'll see a lot of times in this kind of perimeter security type of application as well. From even the camera side, even just what you're connecting and the type of cameras that they're connecting as well. And Xander, I don't know if you can speak to that as well.
As well, I was writing down a second. So this perimeter stack is no longer just cameras. So although we've brought it up multiple times, we have multiple different types of sensors that are out there that are still plugging on this power. And so between what you see there with the PTZ cameras, the thermal imaging, etc., the one that I find very interesting is the gunshot detection, or what is it? Visible firearm detection. Basically, it doesn't necessarily have to be a gunshot. It was just, oh, something looks like a gun itself. And so all of this power aggregation at the edge, it feeds a very large PoE. And so, and the budget that takes from that. And so trying to scale that back down and rein that in financially, you have different fiber cuts that are backing IDF builds and the messy class 1 that's out there. In practice, I think the point that I really want to make is, in practice, we've seen that this can enable 480 watt PoE industrial switches that happen at a distance, but it also gives this clean, future-proof, and that is ready for analytics.
Yeah, it's ready for the bandwidth and power needed, also ready for if you add anything later too. But really that big thing is reducing those telco closets and for power and data and saving pathway being huge, especially on the distances you might be going when you're thinking of perimeter security for sure. Let's keep moving. So kind of giving the overall what we just talked about. So for this type of solution, for this long reach fiber to the edge solution, what we're really saving on is that bandwidth and power over long distances. And that's what you're able to deliver. You're having space and energy savings. Again, that less conduit, less IDF closet build out. Simplicity, you're simplifying your network, right? And ease of use, being able to simply deploy, again, a more simplified network, less pathway, less complex. Working with either your existing switches or customer switches or whatever switch you already have, especially with that media converter type of solution, being able to easily integrate that into whatever system that you already might have, whether you have a copper switch, fiber switch, or you're changing over to one that can work with anything. And also can be installed by low voltage teams. So that whole tomorrow's network today, you're able to plan and also plan for your, not just today, but also for tomorrow, and get your bandwidth and power out along those far distances. next before I think I go into the next one, I think I'll hand it back over to Gayla, I think, to kind of tee me up.
Okay, so now we're going to take a little bit of a deeper dive into what I call option 2, which is you do have local power at the pole, so we're not necessarily looking to bring remote power to the pole. You still need to convert that power over into PoE because those cameras are fed by PoE and also into some sort of copper interface usually at the pole. But you have that long distance and you don't have a fiber splicing crew out there to do these splices at the pole or at the IDF. So we're going to present to you a way of doing it in a completely pre-terminated pre-con solution. So that's what we call a pre-terminated. You'll see here some different looking IDF type of products. These are from Corning, but there are others out in the market as well, where you have completely ruggedized, pre-terminated terminals, as well as patch cords, essentially, that have different type of connectors that then transition you back into your, say, duplex LC type of connector. Again, that doesn't work. So what the main challenges here, as I was saying, is that we're trying to solve for some of these harsh environments. You saw like that wall where you are outdoors, it's rugged. Sometimes these are in very remote areas as well. This shortage of skilled labor is real, and a lot of people are struggling to get splicers to go out on these sites and find the right type of labor anyway to do this work. So this solution will pretty much be a plug and play solution, similar to like what you would do in a data center, but taking it out into these harsh environments. And then of course we're solving for the bandwidth and the distance with the particularly high bandwidth fiber. And again, when we're talking about the type of applications here, right? These perimeter fences, again, parking lots, which seem to be a very big pain point for many people doing camera installs today. Highways, a lot of these ITS, intelligent transportation systems now are putting poles 400 feet apart along a highway with cameras on them. Each pole has to have a connection and it's across many, many miles. So we're working with various ITS suppliers to pre-engineer, I would say, some of these pre-terminated solutions to make the whole thing easy to plug and play. So again, this gives you scalability because, there's a little bit more work to be done up front when you have a pre-terminated solution, but once you have it engineered up front, it's an easy sort of deployment with a big way to just roll it out and plug it in. It gives you the flexibility as well. A lot of these solutions are modular so that you can add and change up your network as needed. And then the biggest one is the speed of deployment, because once you've done that engineering up front and you know where you're going to plug it in, if it comes all pre-terminated on the field, it's a matter of seconds basically to do your terminations. So with that, I'm going to hand it back to Catherine. She's going to go through some components that are involved with them.
First, to kind of reiterate what Gail was just saying. So ease and velocity of deployments in this case are often critical, especially in a lot of those applications, right? And kind of thinking about what's the real difference here. So biggest thing is site survey. You need to make sure you have your links, especially if you're doing a full pre-term solution. How am I going to get from this pole to this pole with this camera and this camera? Where are your distances? That's definitely really key, especially if it's full pre-term, which is something obviously can be helped with. Ordering and takeoff, and actually why is pre-term a little bit better in some cases, and a lot of manufacturers I think do this as well in terms of feeding almost yourselves, right? You want to make sure that we have enough or the manufacturer has enough to be able to supply themselves with the lines. So that's a bit of a cheat code as well. You're thinking of some of the limitations in cabling these days. Cable installation, either way, you're pulling a cable. At the end of the day, it's just a cable. Someone was trying to do this whole spiel and value of what's a preterm cable and what are the full preterm benefits. And at the end of the day, it's just a cable. So if anything goes wrong, you could just splice it. And the biggest savings, though, that you're finding is the fiber splicing and termination. That's really you're saving a lot of this time, that faster installation, that minimized disruption. And and obviously testing, there could be some benefits there as well. But the overall benefits of that is really that faster installation, again, minimize disruption, be able to get find most on-site and off-site quick, as well as from a contractor perspective or installer perspective, someone might be raising their hand and saying, wait, you're taking some work away from me. What are you doing? Actually, well, if you think about it as well, and there's a slight of a, or kind of a benefit to that as well, in thinking of when do you get paid and moving on to the next project. So obviously the people being the bottleneck there, right? I can support the customer, provide the value to the customer, and also move on to the next project. That being said, it's not for every scenario.
Real quick,
Sure.
given the additional size, there's got to be an upsizing in pathway size. What kind of an increase in pathway size and pathway costs are we looking at?
It's honestly not that different, not that much more crazy. I think that very much is a hard question to answer depending on the network that you're supplying and what's the architecture. Is it a pre-term type of solution? I don't even think we'll go full into that. Is that dropping off cables every so, X amount of feet, or is that more of a star topology and it's going more direct trunk? So it does, I guess, depend on the bundle. Is it more bundled all together and then going in different directions, or is that dropped off? So it's kind of a hard question to answer. I think a lot of those.
We do see, so we can do, and we just had a project review where we were looking like, you can go something like 12,000 feet and it'll still fit within a 3-inch duct. So even with the pre-terminated, if you have it fully pre-engineered, pre-termed in a long line, let's say, So the way that these solutions are engineered is you pull it in one direction. So you have to know which direction to pull it in, because it's like a Christmas tree. When you take it out of the box, it kind of just falls in place. But if you pull it in the right direction, they'll all come along. And the OD of the duct really can go from minimum like 1.2, 1.5 up to maybe 3 inches max.
And that's for full engineered.
That's for fully engineered solution.
For the other ones, it's not that, the way that the technology has gone these days, I can obviously speak to Corning's, but for the way the technology's gone these days, it's smaller and smaller ODs to make sure that you're not adding too much more on top. I'm mostly getting into Lego piece approach and want to get into the whole thing today because there are other ways of doing this with pre-term, but just thinking about the pre-term in general, main components, and I think of this, again, the Lego piece approach is one, you have your hardened connectors and assemblies, looking for these IP68 rated connectors, single fiber, multi-fiber for whatever you need. The IP68 being that dust-proof and waterproof, being able to go in any environment. Oftentimes we're seeing this in outdoor environments, although that can be helpful if you're thinking of indoors as well. Think of more of those manufacturing or more harsh environments that you might be going into. That dust proof is definitely helpful, especially if you're thinking of more rugged solutions that are needed. Not just the camera, but also how are you connecting the camera and making sure that connectivity is supported. Second being your hardened multi-fiber terminals. So output ports, whether you need multi-fibers in, single fibers out, or multi-fibers in, multi-fibers out, thinking of those hardened terminals. So instead of splicing, and let's say a small box out at your camera, now I can plug in, and I can also put it in there. So I'm thinking of, instead of needing a NEMA box in every single location, right? Maybe you use a more rugged terminal, like this is an example that can go anywhere on a pole that's more central, or between poles or between areas or zones, you can almost call it. So now I don't need to necessarily put it in a box, although you could, but kind of rugged terminals to think of bringing that back out, and that can go anywhere. Also integrated hardware, a lot of scenarios where there's hardware that actually integrates into a lot of these type of connectors or these ruggedized connectors, to think of what are your maybe standard pieces of hardware, but also these kind of more ruggedized or different connectors that can actually go outside and go inside, right? Or those standard pieces of hardware that integrate with that. So a lot of different pieces. I like to think of this as the Lego piece approach, but there's, again, overall being a trend towards pre-term, the need for that for this security application. And this is maybe what it kind of looks like, right? Instead of using maybe a closure or something like a single panel housing, instead I might use something like this edge application with a terminal, multi-fiber, hardened connector I can plug in. I can now go plug in my drop, and now I'm going to go connect out to my camera. So making it a lot easier, or in this case, maybe not your camera, but maybe you're connecting again right into a media converter rather than media converters close all together near your actual terminal, or maybe it's closer to your camera. So thinking of kind of the design that might look like. And again, that go anywhere strategy, whether you need to go in a strand, on a pole, in hand tool, flower pot, pedestal facade. So thinking of the terminal itself and what are the options there, and what space do you have as well. So maybe not needing a NEMA box now, but I can now go put this into a handhole that's not necessarily where the camera is, but now here are my cameras and here's where I can put this terminal. So just another way to think about the architecture as well. And we've seen a lot of savings in this too. So even up to 32% TCO savings. So material and labor costs combined, I'm actually going to be able to have some savings on that, right? From the customer perspective, and even material savings in some cases up to, obviously that very much depends on the scenario. That's why it's up to, totally depends on what you're deploying, where you're deploying it, all the things. So very dependent, but the biggest thing being that last one, that 57% faster installation time. So from a customer perspective, I'm able to obviously have less disruption, quicker uptime. And sometimes that's even savings or more of a security risk. I need things to get up and running quickly. But also from an installer perspective, I'm able to use my people to the next project or move them to the next location, or I can maybe send my more expertise folks onto the next project and do more hires onto this one. So there's a lot of benefits, not just for the end user, but also you can think about it from an installer perspective. Lastly, I'll hand it back over to Gayla, and we'll do fiber optic sensing before we some questions.
Okay. Any questions so far regarding what we have learned about with the hybrid approach, with the Actify or the hybrid cables, or with the pre-term? Any other questions? Yes, go ahead.
On the cable type itself, is that mostly just outside plant rated, or is it indoor outdoor rated? Because having done a project recently that's got an IDF, and again, it was a non-plenum space, but the plenum piece didn't come into play very much.
Right.
It was a train station.
Yeah, train
Mostly
station.
outdoor. But I can picture other scenarios where it's hitting the building and then needing to be plenum. I was finding when designing this that indoor outdoor rated pre-term isn't necessarily what you're using.
So on the in the pre-term solution, we Corning have options that are both in outside plant as well as FR rated for riser or low smoke zero halogen. We are working on a plenum version as well, because we have encountered some projects that went into the plenum, not as popular. But typically with train stations and tunnels, etc., you need low smoke zero halogen. So we have a dual rated cable that is available in the full pre-term solution that you saw there. With the Actify or the hybrid cable on the Corning side, we have indoor-outdoor as well as indoor plenum rated solutions. So we are thinking more enterprise and more indoor-outdoor. A lot of these products came from our carrier side of the business, which was purely outside plant. So we are transitioning a lot of this into the building with the FR rated versions. Any other questions? Okay, so how many of us have heard of fiber optic sensing?